Hi students, in this session we are going to learn about solubility of solid in liquid and solubility of gases in liquid. Let's get started. Solubility. What does mean solubility? What does mean solubility? The maximum amount of solute is dissolved in a specified amount of solvent at constant temperature is called as solubility. The maximum amount of solute is dissolved in a specified amount of solvent at constant temperature is called as solubility. The maximum amount of solute. See, the maximum amount of solute present in particular amount of solvent. For example, 100 grams of solvent I am taking. So, the amount of solute dissolved in particular amount of or specified amount of solvent at constant temperature is called solubility. Okay. The solubility is affected by nature of solute and solvent as well as temperature and pressure. Solubility is affected by nature of solute and solvent as well as temperature and pressure. Yes. Let's move on. Solubility of solid in liquid. The solubility of solid in liquid. The solubility of solid in liquids. Generally, polar solute soluble in polar solvent and non-polar solute are soluble in non-polar solvent due to similar intermolecular forces. Yes. Polar solute are soluble in polar solvent. Yes, and non-polar solute are soluble in non-polar solvent. It is due to similar intermolecular forces. Polar solute are soluble in polar solvent means, for example, sugar is dissolved in water. Sugar is dissolved in water. Yes. And non-polar solute are soluble in non-polar solvent. See, non-polar solvents are organic solvents. Organic solvents or organic solutes are soluble in organic solvent. It is due to similar intermolecular forces. It is due to similar intermolecular forces. Yes. Next, when solid solute are dissolved in solvent, the equilibrium is established. See, when the solid solutes are dissolved in solvent, then equilibrium is exist. Let's see, solute plus solvent. Solute plus solvent is formed solution. Yes. Equilibrium is exist between solute plus solvent to form a solution. See, in this process, dissolution process and crystallization process. What does mean dissolution? Dissolution means when solid solute is added to. When solid solute is added to solvent, some solutes are dissolved, which is called dissolution process. Nothing but the solvent concentration increases or solution concentration increases is a dissolution process. What does mean dissolution process? When solid solute is added to the solvent, some solute is dissolved, which is called as dissolution process. What does mean crystallization? Some solute particles are colloids. Some solute particles are colloids with other solute. Particles are separated out of the solution. This process is known as crystallization. Solute particles are collide with other solute particles, get separated out from solution, which is called as crystallization process. Yes. Yes, next move on. Solubility of solid is affected by temperature and pressure according to Le Chatelier's principle. Yes, let's move on. Solubility of solid is affected by temperature and pressure according to Le Chatelier's principle. Le Chatelier principle. Yes. If dissolution process is exothermic, what is the point? If dissolution process is exothermic. That means delta H solution is less than 0, then solubility decreases, with increasing the temperature, with increasing the temperature, with increasing the temperature. See, dissolution process is exothermic, the solubility decreases with increasing the temperature. Next, if dissolution process is endothermic, the dissolution process is endothermic, dissolution process is endothermic, delta H is greater than 0, delta H solution is greater than 0, then solubility increases, with increasing in temperature, with increasing in temperature, with increasing in temperature. Yes. Next, solubility of a solid is not affected by pressure significantly since solids are highly incompressible. Yes, solubility of solid is not affected by pressure significantly since the solid are highly incompressible. Yes, this is about solubility of solid in liquid. Solubility of solid in liquid. Let's move on. Solubility of gases in liquid. 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 Gases in liquid. Yes. Certain gases are highly soluble in water. Certain gases are highly soluble in water like ammonia, HCl. See, certain gases are highly soluble in water, like ammonia, HCl. Certain gases are less soluble in water. See, certain gases are less soluble in water, like O2, N2 and helium. See, solubility of gases affected by pressure and temperature. See, solubility of gases affected by pressure and temperature. Affected by pressure and temperature. Pressure and temperature. Increasing in pressure, increasing in solubility and increasing the temperature, and decreasing in solubility. Yes, next, see here, increasing in pressure, increasing in solubility, and increasing in temperature, decreases solubility. Yes, increasing in pressure, increasing in solubility, and increasing the temperature, decreasing the solubility. Yes. During dissolution of gas, pressure of gas decreases, and dissolution of gases is exothermic in nature. During dissolution of gas, pressure of gas, pressure of gas decreases and dissolution of gas is exothermic in nature. Exothermic in nature. Yes. This is about solubility of gases in liquid. Let's move on. Very important concept. Hendris Law. Hendris Law. Yes. Let's move on. Yes. Can you tell me who is the first person to give the quantitative relation between solubility of gases in solvent and pressure? Mr. Henry give the relation. Yes. The law states that at constant temperature, at constant temperature, the partial pressure of gas, the partial pressure of the gas is directly proportional to mole fraction of gas. Mole fraction of gas. The solution. See, the partial pressure of the gas is the P is directly proportional to mole fraction of the gas. Yes. So the partial pressure of the gas, removal the proportional constant is the KH into mole fraction of gas. Here KH is a Hendris constant. And P is the partial pressure of the gas. And chi is the mole fraction of gas. Yes. Here Hendris constant means KH depend on nature of gas and temperature. If KH increases with increasing temperature, therefore solubility of gas decreases. Yes. See, what is the meaning? Solubility is inversely proportional to Hendris constant. See, solubility is inversely proportional to KH. KH is a Hendris constant. KH increases, solubility of gas decreases. More soluble compound has least KH. Yes. Next, more soluble compound has least KH, yes. See, let's draw the graph between partial pressure and mole fraction. Look at the graph. The graph plotted between, see, the graph plotted between partial pressure versus mole fraction. Look at the graph, partial pressure versus mole fraction. See, partial pressure versus mole fraction. It gives straight line. The graph is straight line. Yes. Slope equal to KH. See, look at the next graph. The graph plotted between mole fraction versus partial pressure. Mole fraction versus partial pressure. Partial pressure. The slope equal to 1 upon KH. 1 upon KH. Let's discuss the limitations of Hendris Law. Limitations of Hendris Law. Limitations of Hendris Law. What are the limitations? It is applicable only when pressure is not very high. See, it is applicable only when pressure is not very high. Pressure is not very high. Yes. Next, second one, temperature is not very low. Temperature is not very low. Yes. Gas is not highly soluble. Gas is not highly soluble. Highly soluble. Yes. Gas does not undergo dissociation. Gas does not undergoes dissociation. Yes, these are the limitations of Hendris Law. Pressure is not very high, temperature is not very low, gas is not highly soluble, and gas do not undergoes dissociation. Yes, what are the applications of Hendris Law? Applications of Hendris Law. Applications of Hendris Law. See, applications of Hendris Law. What are the applications? The first application, to increase solubility of CO2 in soft drinks. To increase solubility of carbon dioxide gas in soft drink. Solubility of CO2 in soft drinks. Yes. Now second application is sea divers. Sea divers use air diluted with helium to avoid a condition is known as bends to cope up with high pressure underwater. Next one, at higher altitudes, when partial pressure of O2 is less, it leads to condition is known as anoxia. These are the applications of Hendris Law. Yes. Let's take one problem about Hendris Law. Yes. Let's move on. Right. Yes. Next. H2S, hydrogen sulfide, a toxic gas with rotten egg smell, is used for the qualitative analysis if the solubility of H2S in water at STP is 0.195. Calculate Hendris Law constant. Means KH. Yes. First of all, we can write the given values. Pressure. STP means 1 bar pressure. Pressure equal to 1 bar. Solubility is given. 0.195 mole per kg. Number of moles of H2S. See, number of moles of hydrogen sulfide, NB, it is equal to 0.195. Number of moles of water, H2O, it is Na, equal to 1000 upon 18, it is equal to 55.5. Yes. Let's calculate mole fraction of hydrogen sulfide. Chi B equal to number of moles of one component upon total number of all component. Yes. NB is 0.195 and Na it is a 55.5 plus NB equal to 0.195. It is equal to the value is 3.5 into 10 power minus 3. It is a mole fraction of hydrogen sulfate. Let's calculate Hendris constant. What is the formula of Hendris constant P equal to Kh into mole fraction of gas. Yes, here we can calculate the Kh equal to pressure, partial pressure upon mole fraction of gas. Partial pressure is given 1 bar. It is the 1 bar. Kh, how to calculate? Kh, substitute the mole fraction of gas. It becomes 3.5 into 10 power minus 3. 10 power minus 3. It becomes 285.6 bar. We are getting the Hendris constant Kh 285.6. Okay, thank you.